Any questions at all on number 1? Negative times a negative is positive. That's all it is. Make sense? Any questions at all? Okay, so number 1, we'll wrap that one up. Number 2, been a little while since we've done one of these. Solve and graph this inequality here. Did you guys do a distributed property first?
Yeah.
Okay, so that -5 should be distributed. Please remember, this is something that sometimes people forget. Before you can solve anything, you really need to do a little simplifying where applicable. And so that's what we're going to do here first. So this would be 8 minus 5x minus 10 minus 6x is greater than -24. Any suggestions on what to do next?
Add like terms.
All right, on that left side there's quite a bit, right? So I got the -5x and the -6x. Those will add up to be -11x. And then the +8 and the -10 are also like terms. That adds up to be -2, greater than -24. Okay, now that we've simplified everything, now we're ready to solve. I've got to get rid of the -11 and I've got to get rid of the -2. Which one should I get rid of first? And how do I get rid of -2? Add 2 to both sides, yep. So +2 plus 2. This will give me -11x is equal to -22. And then finally we divide by -11, right? What happens though, what's kind of the unique thing that happens when I divide by -11? The inequality's got to flip around, right? The fact that I divided both sides by a negative and I put equals for some reason. So let's fix that. Should be -11x is greater than, there we go. But then when I flip the inequality, it ends up being x is less than +2. Okay, so then as far as a graph goes, how do we represent that? I've got to put either a closed circle or an open circle on the 2. And I'm going to say that this is 0, there's 1, there's 2. So what kind of a circle goes on the 2? Open, right? Because it's not or equal to. So open circle right there on the 2. Arrow going which way? To the left is correct. We want all the numbers that are smaller than 2. Okay, questions on number 2? All right, so number 3 is about function notation. So you have had a function defined for you. It says that f of x equals -3x squared minus 2x plus 4, and we're supposed to evaluate f of 4x. So if you remember, when you see this notation, that means wherever you see an x, you replace it with 4x. Okay, so maybe our first step would look like this. F of 4x equals -3 parentheses minus 2 parentheses plus 4. Just replace any variables you see with just blank parentheses. And then we're going to put in the appropriate value, and that would be, in this case, 4x. So 4x goes here, forgot to square that one, and 4x goes there. Okay, so now we're going to follow order of operations. So f of 4x equals -3. 4x squared, isn't that really just 4x times 4x? So that would be times 16. And what is x times x? That's x squared, right? That's the definition of what x squared is. And then here, -2 times 4 is -8, so -8x. We still have plus 4. And then maybe a final value here, final expression, f of 4x equals -48. X squared minus 8x plus 4. Are there any like terms for me to combine there? No, I've got an x squared term, but I only have an x term for the second one. Obviously, the last term doesn't even have a variable. So, yeah, none of them are like terms. Okay, so again, questions, concerns? For a lot of these, some of these might feel like it's been a while since you've done them. So I would totally get it if you're like, whoa, wait a minute. F of 4x, what? That makes no sense. I don't know, whatever. Just give you a second to think. Okay. So then our final question, here we go, says, a local bee farmer sells flavored honey at the farmer's market. He sells lavender honey for $7 a jar and lemon honey for $4 a jar. He sold 25 jars last week at the farmer's market and made $160. How many jars of each flavor did he sell? It wasn't real specific here. This is going to end up being a system of equations. Regardless, I want to see an algebraic method. I don't want to see just a bunch of like adding and multiplying and subtracting and see if I can just sort of muscle my way through this. I want to make sure that you know how to set it up. So here would be my very first thing to do, and that is going to be to define my variables. I'm going to say that X stands for lavender honey. I really don't know what that is. Y would be lemon honey. I guess it's lemon flavored honey. Who knows? Okay, so that's what's it's going to stand for, the number of jars of lavender honey, number of jars of lemon honey. Okay, so then I'm going to set this up by writing an equation. I'm going to say X plus Y is equal to 25. It's got to be true. Do you see why that's true? If I take the number of jars of lavender honey plus the number of jars of lemon honey, I'm told here that I sold, or this person sold, 25 jars. So if I take the number of each and I add them up, I should get 25, right? Sold 25 jars. So that has to do with the number of jars that I sold. The other equation that I've got to write here has to do with the money for each jar and the money that I collected. So I am told that he sells lavender honey for $7 a jar, lemon honey for $4 a jar. We talked about this. It's been a while. If I sold X jars of lavender honey and they were $7 a piece, how much money did I get from just those sales? 7X is right. Okay, good. So 7X as far as the lavender honey money goes, plus how much money did I get from the lemon honey? 4Y. Yeah, 4Y is right. And of course, I ended up with a total of $160. Let's see that right here. And so what I have here, of course, is a system. And I've got options as far as solving a system. I could graph this. Probably not the best recommendation here. Could use elimination, substitution. Ava.
Can I say what I did?
Sure.
I did elimination, and I multiplied the x plus y equals 25 by -4.
Because elimination doesn't work right now, right? But if you do the multiplication, I think it'll work just fine. Okay, so if we multiply by -4, we want that pattern of opposites. And I got to say on this one, I think elimination or substitution would work equally well. But I would probably trend, Ava, towards what you did. I tend to do elimination more than I do substitution, but I think substitution would work just as easily here. Okay, so then Ava has created the pattern of opposites on the y's. And so the y's should add out. The x's end up adding to be 3x. The y's were eliminated. And I end up with 60 when I add the constants. So 3x equals 60. Of course, dividing by 3, it looks like this person, this farmer, sold 20 jars of lavender honey. How would I find the number of jars of lemon honey?
Put it back in.
And of the 3 equations that I've got, top, middle, or bottom, which one's easiest? Top, right? That right there is the easiest one because the x and the y already have a coefficient of 1. So it would be 20 plus y equals 25. And then, of course, subtracting the y, you just get a 5. I'm sure you probably did that arithmetic in your head. Right? So then we could finally say 20 jars of lavender honey, 5 jars of lemon honey. And we got it. Okay. So here's another opportunity for you to ask any kind of a question you might have. Maybe it's just a clarifying question. Maybe you got it right, but you used a different method than what Ava suggested, and you're just not totally sure if you did it right. I don't know.
Substitution works too in this.
Totally should work fine. Yep, it would work great.
Whenever the x's or the x or y variable are by themselves, I
Ha-
kind of tend to go for that one.
Yeah, whenever you got a coefficient of 1, I think they're probably equally as efficient at that point, and maybe even substitution be a little faster. I'm in the habit of doing elimination. Sounds like Ava kind of is too, and that's fine. I think it's good that you could do both, and I think your strategy makes sense. Okay, anybody else? All right, so as you guys know, tomorrow is your Unit 3 test. Yeah, and you know what? Questions like number 4, it would not be shocking to see a question like number 4, or really any of those for that matter, on your test. All right, so now is your chance to do some reviewing and some working and working with friends, asking of questions. Let's get going.